Okay, so welcome back, everyone. Let's continue these afternoon sessions with Magnus Bergman, sorry, from CD Network, and he's gonna give us some hints on how to build a public cloud on OpenStack. So, thank you.
Thank you. Hello, everyone. I'm Magnus. Now I work for a company called CD Network, and I'm basically going to talk a bit about building a public cloud on OpenStack. If you start out with the service that we provide, it's called CD Cloud. It's a public OpenStack cloud, infrastructure as a service. There are multiple cloud sites, 8 of them in multiple countries, 6 of them actually. And that's the public cloud, that's the standard. Anyone can sign up, you can start VM pretty soon after signing up. Then you have something called the community cloud. It's more based for customers that have special regulatory requirements. For example, health sector, it might be a bank, it might be a government agency or something like that still wants to be able to use a somewhat public cloud service. Also, there are a number of private clouds for specific customers. Those work pretty much the same way as the other services, but they are built specifically for one customer that have special requirements. All of this is mostly built on standard OpenStack components. What kind of customers actually use our services? They're very different workloads. Some customers really treat their virtual machines as pets. It's really important for them. This is, for example, a customer that sets up a really important Windows server. They might be really, really upset if this server goes down. Other customers use cattle, treat their virtual machines as cattle. And okay, a virtual machine went down, never mind, I'll just start another one here. Or I already have 10 virtual machines, and if one of them goes down, it doesn't matter. And then we have everything in between. So we have a really complex difference between customer expectations. If we talk about a brief moment about the history, where did we come from and where are we today? We started out back in 2009 with the infrastructure as a service, and that was a non-OpenStack, a KVM-based service. It worked pretty well. Virtual machines did work, and the customers were pretty much happy, but we were still finding that we were lacking a lot of features that we really wanted to do. Also, we didn't really like the development rate of the product. And this was a commercial product. This was not open source. We couldn't start implementing our own features or whatever. So we really needed to start looking for an alternative. And we did that in 2012. So we looked around and found OpenStack, and we had, of course, seen about OpenStack before, but we started looking more into OpenStack and did our first test installations, started playing around with it and see how it worked. In 2013, and that started out with Havana. We played around with it for maybe a year or something like that, and did lots of test installations and developed features for the control panels and stuff like that. And in 2014, we launched the first production service based on OpenStack. It was based on Icehouse. So over the years, we have, of course, done regular upgrades. So currently, we're running Mitaka, Newton, and Okata in production, depending on which type of service it's providing, and as well as where in the upgrade cycle it's at the moment. So those setups are in multiple data centers, giving some extra challenges. It's 10 different data centers, 10 gigabit connections between data centers. We can also transport VLANs between those data centers through our core network, which is based on MPLS and VPLS to do that. We basically started out with one keystone and multiple regions in the public cloud. We found some issues with this. Mostly, one of them was, of course, compliance. It might depend on which jurisdiction a specific cloud is located in, and in those cases, it might be desirable to separate the different regions even more. Also, we saw some issues with performance and some issues with some challenges when it came to redundancy if one data center goes down and so on. So we have started separating and distributing keystones instead and separating the different regions into separate OpenStack installations, basically. We have also written some code of our own to be able to move virtual machine snapshots between regions, or rather installations in this case. This code we have not been able to contribute this code to upstream yet, as it's pretty specialized and it's also running on a specific type of storage. And it's dependent on the specific kind of storage at the moment. We'll see if that changes. When it comes to hardware, we have a pretty close relationship with Dell. And when it comes to networking equipment, we use Dell and Dell Force 10 equipment for data center networking. When it comes to the core network, we use Cisco. Both core network and the border network peering points and stuff like that. For servers, we use M1000E blade chassis for most of our the servers powering an installation like this. We also use some non-blades, for example, for storage and some other features where we require actual hardware to be able, either because you have to need more disks or more network interfaces or something like that that you can't get out of the blade. We deploy all hardware through MAAS. I'll get a little bit more into that a little bit later. Okay, then we can talk a little bit about the actual OpenStack platform. When we started out, we began doing some manual installations from the beginning to see how it worked and to play around with it. And it was really quickly obvious that this would not be a way to actually do it later on. So we started out to develop some of our own scripts to deploy those OpenStack in those environments. It worked pretty well, but then we started using Ansible pretty extensively all through the organization. So we converted those scripts to our own Ansible playbooks. In the compliant platform, or rather the community platform, it has actually changed names, so from compliant cloud to community cloud. That's why it says compliant here, but it's the same thing. There we have been using Red Hat. We have been looking at from the beginning to use Red Hat and Director, but instead we did use Red Hat with our own playbooks, and basically the same playbooks as a base that we use for the CentOS installations, with some modifications, of course. Currently, we're actually redoing pretty much everything of this. We have started using MAAS, which is basically it's called Metal as a Service. You deploy the hardware, you install operating systems, you set up networking and all other basic stuff that needs to be done before starting to kind of install OpenStack or anything else. So that is deployed through MAAS, which works really well. Then we use Ubuntu as operating system all through, both for the compliant cloud as well as the public clouds and every private cloud, basically every private cloud also. We're also scrapped our own playbooks and started using OpenStack Ansible to deploy OpenStack. And this, of course, has the pros that we don't have to for every upgrade, we don't have to do research of exactly which features have changed when it comes to installation and upgrade and so on. So we get really much more forgiven instead of having to write it ourselves. Overall, this works really well, and we're currently working on converting some of our older data centers to this architecture as well as every new installation is done this way. Okay, when it comes to vendor support, we have, of course, basically talked to every major vendor when it comes to OpenStack. And we have found it quite hard to find useful support for someone that deploys OpenStack in the way we do. It's also very often very time-consuming to get help, and usually we find a fix before the vendor, you have actually established all the information that the vendor needs to start working on the ticket. We have usually actually already fixed it or found a way to work around it. We have also sometimes from some vendors it has been found a bit difficult, or even in some cases strange requirements to be able to provide support. I think the issue here is that it's easier to get vendor support if you're kind of an enterprise than if you're a service provider like we are. That's what I think, at least. Okay, when it comes to storage, we have historically, even before we started using OpenStack, we have been using ZFS and NFS really extensively. But in the OpenStack environment, when we started out using OpenStack, we went for the same kind of storage as we really has lots of experience with it, and we know all the ins and outs and what problems might occur and so on. So it was a logical choice to start out using it from the beginning. Of course, when it comes to NFS and ZFS, there are some issues with the scalability and redundancy. You basically hook in a lot of storage to a huge NFS server, and then you start adding more NFS servers like this beside the first one, and well, it's pretty much how it's done. We have been looking at a number of technologies. We have had brief encounters with during the years with the vendors like EqualLogic. We've been looking at Gluster and so on. But in the end, we settled for Ceph. Both because most people in the OpenStack environment seems to be really like Ceph, and I can understand why. There is a huge user base of companies and users using OpenStack with Ceph. So it gets really well tested, not only by us. And we get really good redundancy, really good scalability, and it's pretty low maintenance. We don't have to really touch it very much. It pretty much works as it's intended to do. And we have never looked back. Okay, an interesting one, networking. When we started out, we had lots of choices to make how we were going to implement the networking, the Neutron part of OpenStack. There are lots of vendors providing different kinds of plugins that works with their hardware, or that is in some cases hardware agnostic. But we have gone for the standard components as far as possible. Neutron and Open vSwitch, and basically letting OpenStack be as unaware of the underlying network as possible, to be able to basically change the underlying network any way we want without affecting OpenStack. But we have found it to be the most complex challenge of all of our OpenStack implementations. There have been lots of issues over the years. Upgrades, especially early on, was really a pain. We actually saw lots of downtime at sometimes when doing upgrades. We have also had challenges when it comes to performance and stability that we have been working on. Most of them we have either found fixes ourselves. For example, in the configuration and so on. When it comes to upgrades, has also fixed a lot of the issues that has occurred. But we're still working on some issues that we have to improve, and we're going forward all the time when it comes to that as well. But there has been huge improvements since Havana. So, as I said, upgrades have solved lots of the issues, and both when it comes to upgrades of Openstack as well as components like Open vSwitch. In some cases, it has been dependent on kernel versions and stuff like that. Okay, billing. That's an interesting one. We have been using Ceilometer from the beginning. We have seen pretty many issues with Ceilometer from the beginning, so both performance and reliability. That led to some customer unhappiness, of course. If a customer gets a bill that doesn't match their actual usage, customer might very well be pretty unhappy. If it goes one direction at least. So we ended up with writing our own hacks to do basic telemetry. From the beginning, we actually compared the Ceilometer telemetry with our own collected telemetry to make sure that it was matching each other. But we have basically gone over to using our own telemetry to do billing. But it looks much more promising today. So we're actually going to look a bit more into Ceilometer and the whole telemetry ecosystem in Openstack and see what we can do with it today. Okay, when it comes to upgrades, as I said, it can be quite a pain to upgrade Neutron, especially earlier releases of OpenStack. And currently, we're mostly doing quite big release upgrades. We're upgrading from Mitaka to Newton or from Newton to Kata, and we do this during a service window and do a huge upgrade at a single time. In between, we have found that most of the issues, or at least a lot of issues we encounter, already have been fixed or committed in later versions than we run. So in those cases, we cherry-pick those smaller fixes and integrate them into our OpenStack installation in between those huge release upgrades. But we are moving towards a more continuous upgrade strategy. Of course, that has lots of pros. You can, of course, see a lot less time between something being fixed and the customer actually seeing it, as well as that those upgrades will be really small pieces of upgrades all continuously, which means that it will be much easier to troubleshoot if there is an issue with an upgrade. Okay, another thing that is really important is our test environments. If setting up something like this, you're really going to need lots of test environments, both for traditional things that, okay, you need something to develop on, you need the staging, you need things like that. But you're going to want to be able to easily spin up new test environments to be able to, for example, play around with new features, to troubleshoot specific issues and so on, that you don't want to do in production environments. So I can stress that it's really a good thing to be able to very, very easily set up those environments. Basically, click a button is a really nice way to be able to set up test environments. And, of course, throw them away when you're done. Okay, when it comes, what does the customer see? What requirements did we have for what the customers would be able to do with our service and control it? Of course, we wanted to expose the OpenStack APIs, standard APIs, to be able to leverage all the automation tools and stuff like that that is already available for OpenStack environments. We needed an easy-to-use control panel. We already had that for the older product, the non-OpenStack service that we provided before. We needed to support some custom features, like this feature that you could move a virtual machine from one OpenStack installation to another. That needed to be supported in the customer interface. We also want to support some non-OpenStack services, for example, related to backups, to monitoring, and some other services like this. So we needed this to be able to control this in the same control panel. So we actually ended up creating our own instead of using, for example, Horizon. We basically took the same control panel that we had for our previous service and baked in OpenStack support into it. And it works pretty well, but of course it has the con that we have to develop every new feature that shows up in OpenStack or we want to implement. We have to develop support in the control panel for it as well. Okay, during implementation of this control panel, of course, we coded a lot against the APIs of OpenStack. And both when it came to the control panel as well as automation tools and troubleshooting tools and stuff like that. We have found that documentation has not always been up to date, and in some cases, especially early on, it might be plain wrong or be for an older version or things like that. This has improved a lot over time. Now I think that the documentation is actually pretty good when it comes to the APIs. But I guess that's kind of the beauty with open source, that if you don't really, if you don't say that the documentation is bad, you should start writing your own. Okay, what do we do to support this beast? We have a really large variations in customer knowledge. I mean, we have everyone from the customer that sets up one virtual machine and that pretty much looks at it as a VPS rather than something having to do with the cloud, and has a really important server that they set up, to customers that leverage automation and does everything automatically and doesn't really care if a virtual machine goes up or down. Basically, it's a first-line support that takes care of the actual calls or tickets that started from the beginning, and they also take care of easier troubleshooting when it comes to looking at what the customer, if the customer has just done something wrong, or if it has to do with billing or whatever, those kinds of questions. And then, if it's not solved quickly in the first line, it will be escalated to the second line, and they will start doing more advanced troubleshooting, starting to look into the actual OpenStack implementations and to see what the customer issue might be about. In the cases when the second line doesn't solve the issue, it will be moved to the DevOps team, escalated to the DevOps team that will are able to do more intrusive changes in the OpenStack environment, for example, patching or changing configuration and so on. Any questions? Yes? Ah.
Thanks for a great presentation. How are you managing configuration changes after the deployment is done?
We basically run the playbooks. We have a repository of configuration, and we rerun playbooks when configuration changes is made, basically.
I know.
Thank you for a good presentation. My question is regarding upgrade. Do you have any post-test or post-upgrade test to check, actually know you're not gaining any performance or losing any performance or something for the application or services?
Yeah, we do. We of course do testing after upgrades, both before upgrades in the test environments as well as doing the tests after the upgrade in the production environment. But we do have more metrics that we would like to be able to monitor, and generally we want to monitor those all the time, not just after an upgrade, but we want to monitor them to be able to find faults even between updates as well. So I would say that that's probably something you should test all the time rather than doing it specifically after the upgrade. But well.
I have one more question regarding networking. Do you use any DPDK or hardware acceleration in your application or host?
We're actually at the moment looking into DPDK and doing extensive testing of that in test environments. And if that works out well, we'll push it through the production environments as well.
Any other question? Yep.
So you said you are using MAS. Is it the canonical version of MAS, or is it your own, like Foreman or anything?
No, it's a canonical version.
Okay, thank you.
Good. No more question then? Okay, but then thank you very much, Magnus.
Okay.
And,
Thank
yeah.
you.
Thank you.